if something happen on Earth, we can reproduce inside a laboratory, and then we can understand the physics behind why that is happening. But the same thing happening on the moon, it's difficult to do the experiment on the moon, and also it is difficult to reproduce the same setup inside the Earth, because obviously we have a different gravity. We cannot reproduce the lunar gravity on Earth. So, which means there is a knowledge gap that still persists.
My guest this week is Senthil Subramanian. Senthil has a Master's in Aeronautical and Aerospace Engineering from the Indian Institute of Technology, Kanpur. He's got a PhD in Lunar and Space Exploration from the University of Glasgow, and currently he is doing postdoctoral research, still at the University of Glasgow, where he's working with the European Space Agency, the French aerospace lab ONERA, multiple German universities, and this research is on the impact of regolith on lunar activities. Senthil, welcome to STEM with Mr. N.
Thank you, Stuart. Thank you for inviting me for this talk. Let's start.
Well, thank you for volunteering. It's a pleasure to have you on. Can we just start off with, I'd mentioned there in the introduction about your research is on the impact of regolith on lunar activities. Now, I'm sure most people listening understand lunar means the moon, but what is regolith?
All right. Regolith is basically, it's a soil of extraterrestrial planets. So on Earth, we call it soil, but on the moon or asteroid or Mars, we call it regolith. So that's simple as it. So basically, my research is like how when the rocket land on extraterrestrial planet, how the rocket exhaust interact with the soil of the extraterrestrial planet. And I hope that's clear. Right.
Yeah, that's clear. And obviously, you know, it's been 55 years since man first set foot on the moon. Like Buzz Aldrin over my shoulder here was one of those, the second man on the moon. So why are we still having to research the impact of regolith? What's going on in the space industry, and what have we learned, and do we still need to learn?
People went to the moon and they bring back the soil and all this stuff happened. But that's for the short period. But this time, we are planning to stay for a longer time. It's maybe in month. So planning to build habitats. Because the main motive behind this, we are going for a mining, mining minerals on the moon, which means we are planning to stay there for a long time. If something happen on Earth, we can reproduce inside a laboratory, and then we can understand the physics behind why that is happening. But the same thing happening on the moon, it's difficult to do the experiment on the moon, and also it is difficult to reproduce the same setup inside the Earth, because obviously we have a different gravity. We cannot reproduce the lunar gravity on Earth. So, which means there is a knowledge gap that still persists.
The University of Glasgow don't have a campus on the moon, and we can't do research on the moon. So how do you, in collaboration with the other people I'd mentioned, like the European Space Agency, how do you actually conduct research into regolith without being on the moon where the regolith is and with the same gravity?
So in the University of Glasgow, we have a big vacuum chamber. It is called the plume-regolith facility. It's a really huge, 5 persons can stay inside. It's like a kind of room, a big room, but we create a vacuum inside, like the vacuum similar to the moon. And we choose, so we have a vacuum chamber, and we have a rocket, a small rocket, a replica of the actual lunar rocket. And we have the rocket fixed inside. And also, instead of lunar soil, of course, we don't have soil. So we use something called a simulant. It's basically a fake lunar soil. And that is slightly adjusted to the gravity of the moon. Understand what I mean? We adjusted the properties of the simulant, like densities and mass and everything. So it will slightly match with the gravity of the moon. So we have the dust, and we have the rocket, and we have the chamber that created the lunar environment. And we fire the nozzle, and then we have the ejection. And then after that, we use high-speed camera and high-speed laser to track how the particles has been ejected, at what angles they are ejecting, at what velocities they are ejecting.
As well as using the high-speed cameras and computer simulations and things, it sounds like, just reading between the lines, it also involves using a lot of maths within the physics of it. Would that be right?
Yeah, excellent. Yeah, that's true. That's true.
Yeah.
The physics, when you talk about the physics, it's a completely different physics on the moon. Whatever, so far we are much care about the physics on Earth. Say, like, if you want to, let's say, if you want to drill, you have a drill machine, and you can drill on Earth. But on the moon, there is vacuum, so all the lubricant inside the drilling machine will evaporate, and you don't have lubricant, and you have a lot of dust problem. The dust will eject a lot. And another thing which I forgot I mentioned, since it is constantly baked from the sun radiation, lunar soils are more like electrostatic properties. They can stick easily. They have some kind of voltage on it. So when you're using an electronic item near to that, it will get, impact. The electricity from the soil will get effect on the missions. So it's a complete different physics which is going on the moon. So we have to think out of the box, out of the earth, other way. Yeah.
So obviously we launch rockets from Earth, and you were talking about regolith being like the moon's soil. But what is different about how regolith will respond to rockets launching or landing, and how soil on Earth will respond to that?
On Earth, we have erosion from air and water that make our soil so rounded and soft. But on the moon, we don't have air and there is no water, and those moon soil are constantly baked by sun radiation. This means they are dry and they are very sharp. So these they are sharp like glass particles, basically, like knife edges. So when these sharp glass particles, and when the rocket lands, it's going to liberate at very high speed. It's going to eject at very high speed. And on Earth, we have air atmosphere that will stop the ejected particles. And also Earth have a high, greater gravity. So the particles ejected from a rocket on Earth will fall down quickly. But on the moon, we don't have atmosphere. So these soil particles, there is no force to stop the soil particles to fly away. So they can fly for greater distances. And also the lunar gravity is 6 times less than Earth, which means there is less force, full force acting on the soil particles, which means it can fly faster and further, and those particles are like sharp, like a bullets. So now you can understand the problem. It can damage anything in its path, like maybe an astronaut, maybe we built a habitat, and this soil particles come and hit. It's coming with like army of tiny bullets, like it's not a one particles, it's millions of particles, and all like small bullets, very high speed. And then it can rip off anything in its path.
When you're talking about earlier, all the different properties that make up regolith, and I might be going down the wrong lines with this question, but is that why we get such a shine off the moon, is because it's covered in regolith? Is it to do with the properties of regolith that gives the moon its glow?
Probably yes. Yeah, I would say yes. It's a grayish, slightly grayish white. Yeah, that's true. It's a reflection of light from the regolith.
And one of the reasons why I'm fascinated to speak with you is, one of the things I love particularly about space but I've used the moon as an example, is that no matter where we are in the world, we all look up at the same moon, no matter where we are, what borders we have. And I mentioned in the introduction, you got your first qualifications in India, then you're studying and got qualifications at the University of Glasgow, and now you're working with the European Space Agency and the French lab and German universities. How much does STEM open up international borders for people?
As a scientist who work on this, I feel like it's a common for the humankind. We are exploration, trying to explore, and we are working for the whole humankind. So it's open for everyone. It's not specific like a defense project which is closed for only for particular nations or so, something like that. So it's open for everyone. In fact, there is one more thing which I'd like to say, since you are talking about students. It's not about only physics or maths which are involved in this lunar exploration. Since we are going to another world, see, we are going to create another world in outer space. We need people from all the backgrounds. You won't believe that. We need people from, there will be a called lunar economy is going to flourish. So we need people from economic background. Lunar politics is going to shape the world. Because once you found how to extract the mine as the resources, there will be a politics which will be coming around that. So there will need we need politics, ethics, lunar ethics. We need people from ethical background. Law, we need to create new laws. There is not much laws like who, like which parties with whom and kind of things. So people from law, we need people from law, biology, how astronauts going to work there for a long time, because it's not on air like a Earth. We don't have oxygen to breathe. We are not in the same pressure. It's an extreme pressure, extreme environment, extreme temperature. So we need people from biology background. We need doctors, engineers to make build everything like mining. Like you need conveyor belts, you need machines and all this stuff. We need civil engineers because we need to construct things. So you can understand, like, it's need everything, everyone, like teachers, everyone. It's a complete new world we are going to create. So the opportunities are endless. And that's what I would like to say.
Yeah, and I think that is a very important point, is about all the different backgrounds that can be involved in the space research and exploration and everything going forward. But since you mentioned backgrounds, this is a good time to go into your background. Where did your interest in STEM come from?
That's a bit of story from India. Back in my school days, I got I initially got interested in space related stuff like planets and all these things, how the planets exist and what is space, where we are. It's more like a philosophical question, but with a science understanding. And then at that one point, I got an encyclopedia. It was a science encyclopedia. It's specifically for physics and chemistry. It's called Osborne DK Publishers, I think. Osborne Encyclopedia. Back in my school days, it's my high school in India. Was somehow I got completely interested with because the way they are explaining things it's a small book, but they explain everything with a picture and with the little details. They're not you don't need to read a lot of things for that, but they explain a very interactive way. It was very interactive with a lot of big pictures and with a little information, but that will allow you to think more, think a lot. You don't need to study. You can, with your intuition, you can start think. And it has a lot of subject like, I will start with atoms. It's went on with engineering, how the machines works and how this works, how that works, the chemistry, organic chemistry. So completely I was immersed with that. I got a lot of knowledge in that. From that moment, I decided that physics is my thing, which I would like to pursue. And especially I'm already have interest in space. Now I got an interest in physics from this encyclopedia, and both combined. Then I want to pursue my aeronautics degree. And then from there on, I started to build up my career.
And have you had any STEM heroes as you've been pursuing this route in your STEM exploration?
From Indian side, much impressed by the work of Kalpana Chawla. She's an astronaut, Indian-born astronaut. She went to US, America, and then she learned to fly all kind of airplanes, and she got pilot license, and then she finished the PhD as well in aeronautics, and then she applied for a NASA astronaut program, and she got selected, and she flown first time in 1997, and then the second time when she flown in 2003. She died in the Columbia disaster. If that people probably know that about the Columbia disaster, and she's the one of the astronaut in that. She died. She born in a small village in India, and then and she dreamed a really big thing. That she is one of my greatest inspiration of all. And of course, and the favorite Indian, late Indian president, Dr. APJ Abdul Kalam. He's a born in again small family, I mean a poor family and stuff like that, and finished aeronautics. And he wanted to be a pilot actually, but because of his physical condition, he's unable to become a pilot. Then he joined in space research in India. He's the man behind all the initial Indian missions, rocket missions, satellite missions, and here behind the ISRO, to be frank, like he was working with ISRO, and later he became a scientific advisor to government of India, and finally he proceeded to become a president of India, the first man, a president of India. And yeah, he is such an inspiration to everyone. Almost everyone in India know him.
You've got quite a few heroes who started from really humble beginnings and then achieved great things just from having that passion and desire. And that is a great point to lead on to my final question, which I ask all my guests, which is, what advice would you give to children or young people out there who are perhaps interested in STEM but aren't sure what they can do with it or where to go with it?
I would like to say, like, follow your hearts, what your hearts say, dream big. If you like something, you need to build your skills around it, and you should believe it first. The belief is more important. That's what I would like to say. Because if we doubt on ourselves, obviously no one can believe on us. Like, we are the first one to believe on ourselves. So we need to believe on us, on our ambition, like what we are passionate about, what we like, and what we want to achieve. On these things, we need to believe on ourselves, and we need to continuously we need to work hard on that point, no matter what.